Okay, so question number 6. What types of intermolecular forces would water molecules have? Okay, so first let's draw out a water molecule. Everyone knows it as H2O. But oxygen is more electronegative than the two hydrogens. So therefore there's an uneven sharing of electrons in the covalent bonds. So because of this uneven sharing of electrons, a water molecule has a partially negative side where the oxygen is, and it has a partially positive side where our hydrogen atoms are. So if we were to have a second water molecule come in, you'll see that it also contains a partially negative side and a partially positive side. So the partially negative side of another water molecule is attracted to the partially positive side of the other water molecule. So this is called hydrogen bonding. Okay, so this specifically involving hydrogen, but it's also known as like an interaction of the dipoles. So I can also say that dipole-dipole interactions occur in water molecules as well. And another intermolecular force would be London dispersion forces. So London dispersion forces is when the electrons in two adjacent atoms occupy positions that make atoms form temporary dipoles. So these are very weak, but they're pretty common amongst almost every molecule. Okay, so 3 types of intermolecular forces would be hydrogen bonding, dipole-dipole interactions, and London dispersion forces. So the junior tutor said that to answer this question, we need to review first the concept of intermolecular forces. Intermolecular forces are forces that hold molecules together in liquid or solid. In general, intermolecular forces are much weaker than intramolecular forces, such as covalent bonds. Intermolecular forces play an important role in the melting points of solids and boiling points of liquids. The liquid boils when the molecules have gained enough energy to break the intermolecular attractive forces. In the same manner, solids melt when this molecule has enough energy to overcome the intermolecular attractive forces that hold the molecules together. There are 3 types of intermolecular forces. These are dipole-dipole interactions, London dispersion forces, and hydrogen bonding. The water molecule consists of 2 hydrogen atoms bonded to an oxygen atom. Its overall structure is bent due to the electronegativity difference in the oxygen atom. Well, it's actually bent because of the lone pairs of oxygen. That's a different story. Anyways, the oxygen atom forms hydrogen bonding with the hydrogen atom and also carries 2 unshared electrons that cause the difference in electronegativity. Okay. And water is polar in nature. The bonds formed by the hydrogen atoms with oxygen are called hydrogen bonds. Hydrogen bonds are weak interactions formed between hydrogen with a partial positive charge and a more electronegative atom, in this case oxygen. Hydrogen can also form hydrogen bonds with other electronegative atoms such as oxygen, nitrogen, or fluorine. Okay, so I'm just going to say this part is correct. So it gets kind of confusing when you try to think about hydrogen bonding, because people tend to think that it is the bond that is formed with hydrogen and oxygen and like a water molecule. But the actual concept of hydrogen bonding is because of that partially positive side of a molecule reacting with the partially negative side of another molecule. So this is the actual hydrogen bonding. So in the case of the Junior Tutor, when they said that the oxygen atom forms hydrogen bonding, well, I think this part, bonds formed by the hydrogen atoms with oxygen are called hydrogen bonds. I think they might have just misunderstood the scenario. But yep, so hydrogen bonds are the weak interactions formed between hydrogen with a partial positive charge and a more electronegative atom, in this case oxygen. Okay, so hydrogen bonds are weak interactions formed between hydrogen with a partial positive charge on one molecule and a more electronegative atom, such as oxygen, on a different molecule. And then I'll say that dipole interactions and London dispersion forces take place as well.